Hey, what's up, guys? This is Cheng here. So today I'd like to talk about this very classic tree problem on LeetCode, which is number 236, lowest common ancestor of a binary tree, which is also called LCA. So you're given like a binary tree, find the lowest common ancestors of two given nodes in the tree. So we have two examples here, right? So the first one is we are given like this binary tree, and the two nodes is 5 and 1, which is here, 5 and 1. So in this case, the answer is 3 because 3 is the lowest common ancestor of these two, right? So that's that 3 is the answer. And for example 2 here, the for the same tree here, right? We have P is 5, right? And Q is 4. So in this case, 5 is the answer, right? So yeah, basically that's the two scenarios we need to consider. Basically, so the first scenario is that the P and the Q, they're on both left and right subtree, and for the second scenario, those two given nodes are on the same on the same side, either on the left side or on the right side. So what's going to be our approach? So actually the easiest way, for the tree problem is always like the DFS, right? Basically, we are recursively calling this function from the root, and then we're going down until we reach like what a base point, right? A base point where we want to return. For some of the tree problems, let's say we are getting like the height or the number of nodes. So for that things, for those kind of tree problems, we always return when the current when the current one is none, is equal to none. Then we return. It means that we only return when we reach the end, when we're reaching the leaf node, right? Because so for most of the tree problems, we need to basically traverse to all the nodes so that we can get our answer, either like the size of the tree, the diameter of the tree, or the height of the tree. But for this problem, other than this one, we also return whenever we find one of the P or Q. We return whenever we see a P or Q. So we just do it because as you guys can see here, let's say in this case, right? So we start from 3 here. That's our starting point. This is the root, right? And so of course we're gonna have like a left and right, right? So for left and right, we call it DFS, right? For both the left and the right. And so for the right side, we continue doing it. And then we find 1, and then 1 is not the answer, and then we go to 0, we go to 8. In the end, on the right side, we will return a none here. But on the left side, basically, as long as we find a 5 here, right, we return. Basically, the left side will just stop here, and it will return 5 to 3. So in this case, left is 5, but the right is none. And our return logic is if left and right, if both left side and right side return like a value, then it means what? It means that that's the first scenario. It means that we need to return. We return the current node. So this is the first scenario, right? But if one of the left and right is not empty, then we simply return the not non one, right? Node. Because as you guys can see here, if the left, sorry, if the P and Q they're on the same side, so which means that one is on the upper level and one is on the lower level. So which means that as long as we find the first node on either the left side or right side, then we know, okay, that node is our answer, which is the 5 in this case. That's why we can simply always return the if one of the left or right is none, then we simply return the one that is not null, right? So that's the for this example. Let's try another examples here, right? How about which one? How about 7 and 4? If the P and Q is 7 and 4, so what's going to happen in this case? So we start from 3 here, right? And then we go to left and we go to left and right. So on the right side, we won't find anything. That's why on the right side we'll also return a none here, right? But on the left side we are at 5. So 5 is not if 5 is not one of the P or Q, so we continue doing it. We go 6 and we go 2, right? And since 6 doesn't have any child, right? That's why on the 6 here it will return none here. So on the 2 here it will continue going to left and right. But here we have 7, and then we have 4 here. And then our logic says, okay, we have a left and right, then we're gonna return 2 to 5, right? So 5 also have like left equals to null and right equals to 2. Then 5 will return the ones that is not null, which is 2. And then it will return 2 to 3 here. And same thing for 3, right? Sorry, this is 2, I'm sorry. So return 2 here. Same thing for 3 here. So 3 has, okay, so the right side is none, but the left side is 2, and then I will return left side, which is 2. That's why the final answer is 2. Okay. And yeah, I think that's it. How about like a corner case? What happened if the node is 3 and 1? So what's going to happen in this case? Basically, so the first time it will just return 3 because 3 is one of the queue. It was finished within the first recursive call, right? We just return this 3 here. So okay, so let me try to do the coding. Actually, the code is pretty short. So all we need is like DFS, and then we have a define DFS. We have current, right? And then, like I said, if not current, right? We return null, right? That's the leaf node case. And then if current equals to P or current equals to Q, right? Then we return current. And then left equals to what? DFS current left, right? And then right equals to DFS current right. So now, the first scenario, if the left and right both have values, then we know that's the first scenario, which means we simply return the current one, right? That's going to be so the current one is our answer. Else we return left if left is not empty. Else right. Basically here, this is the first case, right? First case. Here is the second case, right? Second case, we return the side that has a value. So this will give us the answer, So in the end, we simply return the DFS of root, right? So if I run the code, accepted, right? Submit. Cool. So how, yeah, and I think time complexity is pretty straightforward, right? Basically, time complexity is the size of the node. Yeah, because the worst case scenario, let's say we have since we're doing this left, right? Basically, it will go all the way to the left. Let's say we have a left, left. right? Let's say we have a lot of node on the left side, but we only have like two nodes on the right side, and these two nodes is our answer. It's the P and the Q. Then what's gonna happen here? So basically, it will loop through all the nodes on the left side, and then it will return a none here, right? And then on the right side, it will return this node, which is the answer. That's why the worst case scenario is the is O of n. And the best case, of course, but the best case is O1, right? We find the answers here. That's the answer. If the root is the answer, then that's the O1. Mm, yeah, I think that's pretty much for it. That's pretty much it for this problem. I find this one is pretty interesting. I just find this problem like today, and I decided, okay, I feel like I want to discuss with you guys about this problem. And yeah, so that's it. I'll stop here. Thank you so much for watching this video, guys, and stay tuned. I'll be seeing you guys soon. Bye bye.